In this demonstration, I'll show you how to find the area of a function using limits and Riemann sums. Let's start with question 1. Here we're asked to find the integral between 0 and 1 for x to the power of 2 dx. The first thing that we'll do is set up our problem like we did in the video where we used right endpoints. And the way we do that first is by finding the change of x, which is 1 minus 0 over n. We also found our initial I, which was your initial x, 0, plus I over n. And this leads to I over n. And we placed it like this. A is equal to the limit as n approaches infinity for the sum of your initial, which was I over n, times your change. And since our function is x to the power of 2, we would replace this with the following. The limit as n approaches infinity for the sum of the function I over n to the power of 2, 1 over n. Now that we have this set up, we'll take this 1 over n and place it at the front. 1 over n, limit as n approaches infinity for the sum of this, and also I'll distribute that 2 to both of these terms, both the numerator and the denominator. And similarly, what I'll do now is I will separate the n's from the i's, so that eventually I'll end up with one of these, and I can replace the I with one of these Riemann sums. Here's what I mean. This can be separated where you have I to the power of 2 times 1 over n to the power of 2. And I can take this 1 over n to the power of 2 and place it outside of the limit. The limit as n approaches infinity for the sum of this function I squared. Now I'm going to replace I squared with the Riemann sums shown here, where you have n times n plus 1, n times n plus 1. So we're going to replace now all of this with the following. 1 over n to the power of 3. I just multiplied these two together as the limit of n approaches infinity for this over 6. And now what I can do is I can bring this back into my equation. And if I do that, I end up with this. The limit as n approaches infinity for n times n plus 1 times 2n plus 1 over 6n to the power of 3. Now if I expand this, I end up with the following. If you expand the top, you end up with 2n to the power of 3 plus 3n squared plus n over 6n to the power of 3. At this point, you'd need to take the limit, but it appears to be difficult. So what you can do is you can use L'Hopital's rule, and I do have videos dedicated to that, where you take the derivative of the top and the bottom as many times as possible until you reach a verdict for this limit. So let's do that. Let's find the derivative of the top and the bottom. If we find the derivative of the top, and I'm just going to use h to represent L'Hopital's, we end up with 6n to the power of 2 plus 6n plus 1. And at the bottom, we end up with 18n to the power of 2. Now, all I'm doing is using the power rule here. But still, you can't find the limit of this, so I'm going to use L'Hopital's rule again. And I end up with 12n plus 6, power rule, over 36n. Once again, I'll use L'Hopital's rule to see where I end up with, and I end up with 12 over 36, which is equal to 1 over 3. And so therefore, the limit as n approaches infinity is equal to a third. Now let's do the same thing for question 2. In question 2, they want us to find the integral between -2 and 4. Now let's set it up first. And the way we set it up is finding the change of x, which is equal to 4 minus minus 2, which is equal to 6 over n. Your x initial will be your initial x of -2 plus 6 over n I. And we're going to place this into our formula. A is equal to the limit as n approaches infinity for the sum of your x initial, which was negative 2 plus 6 over ni, and you multiply that by 6 over n. And now what we're going to do is replace all of this into our x. And if we do that, we end up with the limit as n approaches infinity for 3 times negative 2 plus 6 over ni minus 6. And here we have 6 over n. The next step will be to expand this. And if I do that, I end up with the limit as n approaches infinity and the sum of negative 6 plus 18i over n minus 6. And that remains the way it is. These two become negative 12. And at the same time, I'm going to bring the 6 over n outside, where I have negative 12 plus 18i over n. Now, what I'm going to do next is give this limit to both of these on their own. Here's what I mean. 6 over n, the limit as n approaches infinity for the sum of negative 12, and the limit as n approaches infinity for the sum of 18i over n. And now I can separate these, and if I do that, I end up with, first, this becomes negative 12n because of the following reason. And this becomes plus 18 over n. And then we have the sum of I. We're going to use our Riemann sums, which was denoted right here, n times n plus 1 over 2. And I will now fully expand this. So the limit as n approaches infinity, and I'm going to multiply all of this in, gives me 6 times negative 12 is equal to negative 72, and then the two n's will cancel out, so you just end up with negative 72. And 6 times 18, let's just put these together. Maybe we can cancel them out later without evaluating. 2n to the power of 2, so this will cancel with one of these. This will cancel with the 6, leaving us with 3 at the top. 3 times 18 is 54. So let's write that down. The limit as n approaches infinity is negative 72 plus 54 n plus 1 over n. And the limit as n approaches infinity for these two will become 1, because you have infinity over infinity, which is equal to 1. And then you have negative 72 plus 54, which gives us negative 18. So there you have it. Those are two examples on how you can find the area using Riemann sums and limits. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.